Good evening, everyone. Welcome to the Misconceptions in Physics video. This is the 115th video on the video series of Misconceptions in Physics. If you want to see all these videos, you can visit to my website, which is here, which is ratankar.com. And if you want to get notifications, you can always become a subscriber to my channel. So this will really help you out. Okay, without wasting more time, let us begin with our presentation and see today's video. So far, I have been working on one theme, which is nothing but comparison problems. So what are these comparison problems? Comparison problems are those problems wherein you will be comparing two parameters, okay, in a given problem. That's what it is. And towards it, the basic theme or the sub-theme here is nothing but comparing distances. So far we have seen six such problems, five such problems on comparing distances. There's a sixth problem. Now let us look at it. If you want to look at the complete series, then maybe you can visit to my website, or maybe you can visit to my YouTube channel, and the one which you're watching over here, you can become a subscriber. You can see one by one, like how does each problem differ and how does the complexity start evolving, and what is the way to solve these kinds of problems. Given the same concept, equations of motion, now how do you use these equations of motion to solve several different types of problems? So this is what we will be looking into. Okay, now we have come out with a new problem here. The problem is a ball A is dropped from the top of a building. Once again, the same type of problem. So earlier also we had dropped the same type of problem here. So let me just tell you briefly what we have been doing so far. In the first problem, we just dropped a ball A. There were two balls we dropped together, and then these had different masses, and as a result of it, we dropped it. Okay, one was dropped now, and later on another ball was being dropped, and we asked you like what is the ratio of the distances traveled by each ball. Okay, and then the same question was asked for the ratio of the velocities and the ratio of the accelerations. And then we also looked at what is the let me show you. I have forgotten completely. Yes. Okay, so this is what we have. And then we have seen this is MCP2, MCP3. This one. So when you drop a ball over here, its velocity is v at a given height h, and then when the height is increased, because as the ball starts coming down, its velocity will increase to 2v. At what height will the velocity becomes twice? So that was one more question being asked, and we tried to solve it, and we found out that the new height h2 will be equal to 4h. And then we also looked at, okay, comparing distances in opposite directions, wherein two balls have been dropped. One ball is being dropped down vertically, and the other ball is being pushed or thrown upwards vertically. And as a result of it, okay, so where does the ball meet? That's what we have looked at. And we have derived an expression, and we got an expression here. The value of it was seen to be 9 by 51. And then we also looked at, okay, MCP5, wherein two balls of the same mass were being dropped, but such that the kinetic energy of this ball is equal to the potential energy of this ball. Because when you raise a ball to this height and you are dropping it, this will have some potential energy. With the same kinetic energy, I am going to drop it. Which means what? Which tells you that the ball definitely will reach this point. So when we ask this question, so definitely the people thought that it will meet at the middle, but it doesn't meet at the middle, but it meets somewhere else over here. So I have described this over here. It says that the ball which has been thrown upwards meets at 225 meters away from here. Okay, so this was a misconception. Do not just consider, okay, a problem logically, but do understand it and then resolve it. Now let us look at the new problem, which is about comparing distances in a collision. Now ball A, now you have a ball A which is being dropped from the top of a building at the same instant, and that a ball B is thrown vertically upwards from the ground. So you have a ball B which is being thrown vertically upwards from the ground, and let me call this velocity as some UB and this velocity as UA. And clearly when you say it is being dropped, you can just say UA should be equal to 0. Now, when the ball B is thrown vertically downwards, when the balls collide, now in the earlier case, I just said it meets. Now it says collide, which means both of them are being thrown in the same line. Let us say at some point here, they collide. They collide over here. They collide over here. When they collide, what can happen? This ball can move backwards. This ball can move forward, backwards like this. So when the balls collide, they're moving in opposite directions. So they start bouncing here, right? You keep something like an object over here. It collides and then bounces back. It's okay. Here also it collides and bounces back. That's what is happening. So then this becomes your VB, this becomes your VA. Okay, so velocity at this point is VA, velocity at this point B. Then, and the speed of A is twice of that of B. So VA is twice that of B. Okay, so this is given to you. Okay, so this is the way how you need to analyze the problem. At what fraction of the height of the building did the collision occur? At what fraction? At what fraction? Where did the collision occur? Simple. Okay, so we need to look at it. So the student response here is that assuming that the collision, first what he did was, he considered that, okay, if I throw a ball from here with a velocity ub, then he just looked at the way how he does is, okay, I need to work it out, otherwise he will not be able to get to know what was the misconception or where did he make a mistake. Okay, so towards it, what he did was he considered VA square is equal to UA square plus 2G. Let me consider this height as X, this height as H minus X, 2G into X. This is what he considered. And putting UA equal to 0, so we write VA square is equal to 2GX. This is what we get. And similarly, if I consider this distance, now I have VB square is equal to, VB square here is equal to UB square plus 2G into H minus X. I've used V square equal to U square plus 2X, and UB square I do not know, which is just said U, and then 2G into H minus X. I can just write like this. Now what he assumes is that if the collision does not happen here, okay, it's a special case. If the collision does not happen, with the velocity that you gave over here, UB, this particle would have completely gone until here. So based on this, he has just considered H is equal to U square by 2G. Okay, or you can say that this is UB square over here. Okay, because you are throwing it from here. And he says that this should be UB square should now be equal to 2GH. That's what he took. And thus he got this answer as 2GH plus 2GH minus 2GX. That's what he got. And then finally what he did was he writes this as 4GH minus 2GX. Then what he does, he says that VA equal to 2VB. Okay, since VA equal to 2VB, now what we'll do is we'll substitute here. So I will substitute this formula here, which will now become 4VB square is equal to 2GX. Okay, 4VB square equal to 2GX. And now for VB square, I already know this value. I'll substitute it. 4 into 4GH minus 2GX is equal to 2GX. This becomes, I do one thing. I'll simplify here. 2 1s are 2 2s are. This will become 2 into 4GH minus 2GX is equal to GX. Expanding this, I get 8GH minus 4GX is equal to GX, or 8GH is equal to 5GX. So this G and this G goes away, and thus he gets the answer as X equal to 8H divided by 5. Now let us understand what is the mistake here. So when you come at this point, X equal to 8H by 5. Now this is really a blunder. Why is it a blunder? Let me show you. What is 8H by 5? Which should be, if I divide 8 by 5 over here, you get 5 1s are 5, 5 6 are 30. Okay, so you get 1.6 over here. Or in other words, you should get X equal to 1.6 times H. Now what do you mean by that? This X is equal to 1.6 times H. The total height of the building itself is H only. This itself is H. Now when you say 1.6 H, that means this ball met this ball only at a distance here. Okay, ball A met ball B at this distance. Is this possible? It is never possible, right? So this is the misconception. You know, physics always looks at, okay, if you are doing correctly, it will give you the correct answer. If you are doing an incorrect thing, it will automatically show you something. Okay, but generally students, what they do is they think, okay, we have arrived at an answer and we'll stop here. Okay, so that is incorrect. So see to it that this is what is the answer you get. Okay, so this is incorrect. This is a misconception. You should not do it. When I say there is a collision happening, so definitely there is a collision happening there. Do not consider that there is no collision happening once again. Okay, so which is incorrect. Okay, now let me move on. Oh my God, let me introduce a new slide. I have put the next problem over there. Just give me a moment. Okay. Now let me go back. Now, how do we solve this problem? So we have seen what is a misconception here. So while you solve a problem, though you might have come across a situation, it is always true that you throw a particle with a velocity u, it should go upwards covering a distance h, and this formula is right. Okay, but not in this context. In this context, the ball is not made to go upwards. It goes to a certain distance and it collides and it comes back, right? So therefore, you are not supposed to use this formula there. Concept is right, context is incorrect. Okay, now let us start solving on this. Once again, let me explain this problem. I have a building of height h. You threw a particle from here, ball A starts coming down like this. It meets ball B at this point. Ball B at this point, it collides with it. And as a result of it, this goes upwards with a velocity VA, and this comes downwards with a velocity VB. This is what we have. And then here it is given that the speed of A is twice the speed of B. VA is equal to 2 times VB. Same method, nothing else. Now let me change something here. Now what we need to do is, let me consider the time taken by the, if suppose the time taken by the particle by ball A to reach this point is time t. In the same time, this particle that I have thrown here will also reach this point. Only then they can meet together, right? So therefore, now we is right, VA is equal to UA plus GT. Or in other words, UA is 0, initial velocity 0. G, I'll just write, maybe if you are concerned with the axis, I'll consider this as my x-axis, this as my y-axis. In that case, this becomes minus VA. This becomes minus VA is equal to minus G into T. Or you will write VA is equal to GT. Okay, we have got one equation. We've got one equation. Next, what do we have here? We'll do the same thing for VB also. Now VB, what is VB? VB is nothing but you throw the particle from here with a velocity u, and then when it comes here, it reaches this point at a time t. So therefore, you can write u minus gt. Why minus gt? Because anything that is pulling downwards, this vector is always negative. Here also we put negative only. Oh my God, wait, I'll write this. Okay, here also we put negative only. Okay, and this negative cancels, so you get this value as positive. So u minus gt. Now we have arrived at an expression for VB and VA. Now what do we have here? We have VA is equal to 2 times VB. Okay, let us substitute that. So when we do this, what do we have? VA is equal to 2 times VB means GT, for VA, I'll substitute this. For VA, I'll substitute GT, should now be equal to 2 times, what is VB? VB, we have got U minus GT. Okay, 2 times U minus GT. U minus GT. This should be 2U minus 2GT. Or you can now write U should now be equal to, when this 2GT goes to that side, it becomes 3GT, and this will be 2U times equal to 3GT, or U should be equal to 3GT divided by 2. Okay. Now what I will do is, let me put the value of T, G equal to 10. When I do this, I get 3 into 10T divided by 2. 2 1s are 2 5s are, which should now be 15T. What have we got? We have got the initial velocity of the throw. Now what do we need here? We need this x. See, this is called as x. That's what we have called x. And this is h minus x. H minus x. Let us find x. X should be given as ut plus half at square. Okay, half at square. Now what is u? When you would say you are dropping, this becomes 0. 0 plus half into, what is a? A is nothing but minus g. Let me write minus g itself. Minus g into t square. Now what about displacement? Displacement is also in the negative direction. So I will write minus x equal to minus half gt square. Or x is equal to half gt square. Okay, we have got one equation here. Let me circle this. Now let me apply the same formula here also. H minus x. H minus x, this is positive. You cannot put negative here like this way. Okay, h minus x is equal to ut plus, let me write down the same equation once again. Half at square, which should be, what is u? U is nothing but we have got the answer 15t here, right? The velocity of throw 15t multiplied by t plus half into, what is a? Minus g. Minus g into t square. What is g? G is 10. So 2 into 2, sorry, 10 divided by 2 is 5 over here. So I should get 15t square minus 5t square. Okay, g by 2 is nothing but 10 by 2, which is 5, right? So thus, yes, okay. So thus, this should now be equal to 10t square. 10t square. Now what do we need? I need the value of x by h minus x, similar to the problems that we have done, which should now be equal to, what is the x value? Of gt square. Half gt square, which is nothing but 5t square. 5t square divided by 10t square. Right? I substituted there, nothing else, which should just be equal to half. Okay, which means what? This particle and this particle will meet together at the middle point. At last, I gave the student 6 problems, and finally he got one of them to be, if he answered, okay, half is the prominent answer. He likes that answer very much. And ultimately he said, sir, it met at the middle. Okay, at least for this question, it met at the middle. See, all the 5 problems that he has solved, in every problem he thought it will meet at the middle. See, so the answers will be correct based on the context. Okay, just learning a concept will not be sufficient in physics. You also need to know when to apply that particular concept. In which context do you want to apply it? Thank you, friends, for watching this video. If you like this video, do share and subscribe to my channel for more updates. Thank you very much.